In this video, we're going to work with a real-world pipeline. Now, because real-world pipelines are much more complex than the examples we've been looking at to date, I'm going to combine tool usage because this is really more reflective of how I work in the real world. So first, again, this is from the lesson section. You can see the URL here. We're going to just retrieve using wget not only a WDL file, but we're going to retrieve also the sample data files and other files that we need to run this workflow. So you can see that this points to a GitHub repository that's hosted by the Broad Institute, and it's under the viral pipelines section. And the wget is going to be zipped with tar.gz, and then we'll untar it into a directory on whatever execution environment, and then we'll switch to that directory. That's the CD viral pipelines. So I've already done that into our execution environment, and the first thing that I would normally do if I were to get a WDL is I would use the miniwdl tools that we've been looking at so far to help me understand what that WDL or set of WDL files is doing. So let me show you what that looks like. So the first thing that I've done here is once I have downloaded the source files, and you can see the tree over here, I've kept the existing untarred directory structure basically and navigated into that directory. And inside of there, in the level of pipes, WDL workflows, I've run miniwdl check, and just one of, because there are a number of workflows, we're going to work with assemble ref based WDL, and I've added the flag no shell check, which you would remember would cause us to not use the shell verification tool, which we've not been using in this course. Now, if you can see the output here, you might remember from a previous video, what this does is this gives us, number one, an outline of the particular WDL file. Then it gives us any sort of errors that are found when this is parsed. And then something new that we're going to have here is in longer WDL files, there is what's called a top-level workflow, which has calls to defined WDL tasks that are defined in separate WDL files. And the directory structure here should kind of give you a clue on this. WDL workflows, there's a separate directory structure, WDL tasks. So if we drill in and take a look at that, if we go into pipes and WDL, you can see we have tasks and workflows. So if we go into the assemble ref based and we open that up, in lines 3, 4, and 5, this is a really common production level WDL pattern, which is because the files get too long, basically. You import your task description files, which are in separate WDL files, and you associate that with the top-level workflow, which simply calls those. So we've got some additional metadata here, which is also good practice when using WDL, when you're using production, so meta and parameter meta. And then if we scroll down, you can see on line 58, we have a scatter, and then we call from the assembly task file the align reads task. So in other words, this is just a list of called tasks. The definition for align reads is in a task WDL file, which you can see is referenced up here. So in the tree, if we go back up, we have task assembly. There we have a task definition here, and we do not have a workflow. So this is a really common pattern. You can see this is a pretty long file too. It is how long? 600 lines just for this one task. So again, this is a more common pattern. So when you are trying to work with these multi-layered files, miniwdl's capability to check is checking not only for the syntax of the top-level WDL file, but also any imported files, which can be super, super useful. So first of all, it's outlining. So you can read in a more concise format what this workflow is doing. So you can see the workflow and the calls. And then you can see here the assembly. This is the referenced task file, which again is a really nice feature. Basically aggregates both the workflow and the reference task files. Now you can see inside of here you have some syntax information. You've got this information here on line 49, column 48. The forward reference to reads unmapped BAMs precedes its declaration. So again, it's not incorrect, it's just not best practice. So if we wanted to fix that, we would go to line 49 here, and you can see that the declaration actually comes after. So we could go ahead and just make that change. Save this file. Then we can rerun this check. And you can see now I've fixed that error. Now notice in the task files, we have some tasks that are defined but not called in the main workflow. So, again, that's just a choice. We could either remove that code if we're using source code, comment it out. The idea is to make the code as concise as possible. Now the next tool in miniwdl that we could use to work with this workflow is to call it with the run command without specifying any of the parameters. And this would help us to quickly understand what parameters would be required in order to run this. And you can see here we've got a file array for unmapped BAM files and a reference FASTA file. And then we have a whole bunch of optional inputs here. So you can see those listed. And then we have our outputs. And then of course we have in red on the bottom what we would need to run this. Now in this exercise file, I have the syntax for you to run this with direct parameter assignment. And this assumes the same directory structure. So you can see that the required inputs, the reads, unmapped BAMs, the reference FASTA, and the sample name are specified here. Now if you have a different directory structure, you would need to specify that, or optionally, you could use an inputs JSON file to specify that. Now to run this, you want to be at the top level here of viral pipelines. Then you just want to paste this in and go ahead and run this. Notice we are using the verbose flag here. Now this is going to take a couple of minutes to run, so you can see from the directory structure over here that I have one complete run already. Although this one might be pretty fast because of cache. There's a caching by default here. So if while this is running, I drill in, you can see the task status, by the way, I want to point that out, the finished tasks ready running, the reserve CPUs and the RAM as the verbose output is being generated. And so I can just go into a previous run, and I can take a look at this and see that this is the active one because it's being added to right now as the tasks are being completed. So I'll go up into the previous one that's completed. And you can see here's a set of information for each one of the tasks. As we saw in the previous video, we have the workflow log, which is basically this. We have the rerun, the inputs, the outputs, the whittle, the top level out, and then at the task level. So if we go into the call align, the reason we have multiples in some of these is because we have a scatter. Again, we have the same type of information along with the standard out and standard error if there was some sort of error. So it really is the same pattern, but just scalable. So this will take a couple minutes to finish. Now, like I said, in the real world, these workflows are pretty complicated. And so when you're trying to figure out if there's an existing one that you can either run with your data or you can modify somehow, there are some other tools in addition to miniwdl that I like to use because, for example, in this case, this was from the Broad Institute. And if you just go out to their GitHub repository, it's not really designed for browsability. You kind of have to know what you're looking for. I mean, clearly we were in the pipes directory and we were in the WDL and the workflows. But, are you really going to have time to read all of these? So the obvious question is there some sort of visualization or directory or metadata? And there actually is. So emerging in this area is a bioinformatics directory of workflow artifacts. And what I like to use that actually this is listed in is called Dockstore. So when I am working with WDL files, I often will go to Dockstore and I will search to see if there is an existing file. And you'll notice here that we have a lot of different kinds of metadata. As of this recording, we have 487 different WDL files. We have some other workflow type of files. We can search by author, by registry for the Docker containers, by namespace, organization. So organizations is relatively new, and the idea is to address that challenge that I was just talking about. If you are in a GitHub repo, how do you find something? So the idea is to put metadata around WDL workflows so that they're more discoverable. So in the case of Broad Institute, they've set up as an organization, and you can see for this particular repo, they have a Dockstore collection that gives you visualizations, which can help you to more quickly identify if the workflow is going to be useful for your particular research question. And then when you drill in, what Dockstore is it's metadata on top of GitHub. In the case of WDL files, it points to them basically, and on top of Docker images, so Docker Hub or some of these other repositories. Now, a great tool that I like to use inside of here is the DAG, which is the visualization tool of the workflow. And it just really helps me along with the metadata so that I can get a sense of what the workflow is doing. It's kind of a complement to the miniwdl check feature, which outlines the workflow. And if you pass your mouse over this, you can actually see the different files that are associated to this. So I like to use these tools in combination, so I wanted to share them here. Now, we've quickly gone through the basic functionality of miniwdl in this short series, and again, I would point to the top-level course if you are new to WDL. It has more examples that start with language features and then goes into pipelining and then tool examples along with reference material. In addition to that, the miniwdl Read the Docs goes into more detail about run optimization and best practices, and gives you the opportunity to see even more information about working with the miniwdl tool. So I'm Lynn Langett, and happy pipelining.